Look at the frustration on this child's face. When you hand a 6-year-old a standard 4-digit subtraction problem, you are asking them to process abstract symbols that hold no weight or reality in their daily lives. The numbers are just marks on a page, leading directly to the sigh you see here. We can bypass that frustration entirely. A 6-year-old is perfectly capable of solving a complex 4-digit subtraction problem if we stop treating it like a math test. Instead, we translate the abstract numbers into a tangible, puzzle-like shopping story. To set this up, you only need 3 basic physical items: some blank paper, 4 colored pens, and a set of toy money for thousands, hundreds, tens, and units. Before you begin, adjust your own expectations. Your primary objective as a parent or teacher is to praise the steps the child takes to solve the puzzle. Arriving at the correct final answer is a byproduct of the process, not the goal itself. A 6-year-old's brain is highly developed for physical play, but it hits a hard limit with abstract reasoning. By simply placing physical objects into their hands, it allows them to apply their real-world logic to a complex math problem. We write out the equation 3,765 minus 2,758, dividing it into 4 distinct vertical columns using 4 different colors. We add a roof to each column, creating 4 separate rooms: ones, tens, hundreds, and thousands. Next, we assign physical currency to each room. Now we introduce the shopping story. We define the top number, 3,765, as the exact amount of money sitting inside their wallet. The bottom number, 2,758, is the price of the toy they want to buy. By giving the numbers a physical space and mapping them to everyday objects, the intimidation of a 4-digit number disappears. In this format, 3,765 becomes a literal wallet full of bills and coins. Zooming in on the ones column, we hit the first logical roadblock. The child has 5 1-yen coins in their wallet, but the item costs 8 yen. You ask them, how do we buy an 8-yen item with only 5 yen? This is where traditional teaching often fails. Textbooks tell the child to borrow from the next column, but to a 6-year-old, borrowing implies a debt. It means they have to return the money eventually, which creates a confusing narrative loop that derails their focus. Instead, we change the vocabulary. We call this making change or the magic exchange. We tell the child to walk over to the neighbor in the tens room and ask them to break a 10-yen coin. We physically take 1 10-yen coin out of the tens room, move it into the ones room, and swap it for 10 individual 1-yen coins. The child now has 15 1-yen coins. Paying the 8 yen leaves exactly 7 yen. The ones room is complete. Replacing the concept of borrowing with a physical exchange perfectly aligns with how a child understands real-world money. They aren't doing complex regrouping. They are simply breaking a larger coin to get smaller change. Moving to the tens column, the child only has 5 10-yen coins left. 5 minus 5 leaves exactly 0. Looking at the hundreds column, the transaction is straightforward. 700 yen coins minus a cost of 7 leaves another 0 at the bottom. In this footage, you can see how rapidly a child sorts these physical objects. Once the mechanical logic of the exchange makes sense, they enter a flow state, moving through the remaining transactions without hesitation. Finally, in the thousands column, 3,000 yen bills minus 2 leaves a single 1. Zooming out to view the full board, we read the numbers left in each room from left to right: 1, 0, 0, 7. The final answer is 1,007. By clearing the initial hurdle of regrouping with a visual exchange, the rest of the 4-digit problem becomes a series of trivial single-digit math questions. Getting the correct answer of 1,007 proves the system works, but the milestone is the child's ability to navigate the exchange without confusion. They have followed a logical sequence to resolve a problem that previously looked like a wall of static numbers. Direct your praise toward the specific actions they took. Compliment them for being brave enough to visit the neighbor's room to ask for change. Reinforce the process so they learn to trust their own problem-solving skills. If your child's attention span begins to fade, stop. Give them explicit permission to solve just 1 single column per day. Consistency and positive reinforcement matter far more than finishing the entire equation in one sitting. Take this method off the paper and apply it at the grocery store by letting your child hand the physical cash to the cashier. For a deeper dive into making sure your child grasps the concept of 10-unit groupings, click the supplementary video linked on screen now. True mathematical fluency at a young age requires concrete evidence. By turning abstract systems into physical, logical realities, you give a child the tools to build their own confidence.